Hi, it's Aminat here. This is a 1 p.m. external prac for MATH7501. Can you hear me? Okay, good. All right. Today's prac is about for you guys to be able to do your assignment. Okay, the first thing is this handout is not yet complete. It need to be filled with codes today, and the plan for today's prac is for you guys to be able to do your assignment. So these questions are not exactly the same but similar. So I hope you can follow these steps to get you going with your assignment questions. The assignment is available on your course website. Please follow the guidelines on the course website given for submission. So today's prac will contain questions give you help with questions 1 to 4. And I've given you some resources where you can refer if you want to do this with Mathematica. The first question is about matrix operations. So the first question consists of like matrix multiplication, transpose in matrices, checking whether a matrix is symmetric or not, and whether one of the matrices is invertible or not. So the first question on this handout is for you guys to be able to do question 1. And question 2 is about the first part is creating matrices using a given expression. We'll do this using Mathematica and also by hand, and then proving a formula for sum of k and use Mathematica for to obtain a formula for k squared, and then checking some property of a matrix. Okay. And question 3 is about the product rule, matrix commutative rule. So in general, matrix multiplication is not commutative, and you're gonna show this in this question using Monte Carlo experiment. And question 4 is you will need some trigonometric identities, which are given below here. If you download this notebook as it is from GitHub, there is a mistake here, like this should be plus minus. I've corrected it now. Okay, all the codes and the completed notebook will be uploaded on GitHub after this tute. So maybe tomorrow or day after, just look for it. And I've also completed the first prac codes as well. Okay, let's start with the first task. Create matrices A, B, and L. 2A, 2B. Did you mean these two questions? The task in creating n by n matrix? In assignment. Question 2A is for purely for you guys to create those two matrices and compute multiplication of those two matrices. And question 2B is not really related to question 2A, so you just need to prove the formula. Okay, let's start with this one. From previous practice, you must have learned how to create matrices. Let's do this one. Oh, by the way, the last part of question 2 is related to that formula. Do we write the proof by hand, or you can write the proof by hand? Okay. And if you can show it in Mathematica also, it's up to you, whatever you are comfortable with. Okay. Just follow the guidelines of submission guidelines which are provided. Okay. Let me create this matrix. A is, you can create the matrix using, the A is a 2 by 3 matrix. Okay. Either using insert, table, insert, table matrix, new. A is a 2 by 3 matrix. Okay, and then fill in. So let's say this is 2, 1, 3, whatever value you give, or doesn't matter. 1, 4, 2, okay. And if you want to see the output, say this output is in list form, list of lists. So if you want to visualize it, you say apply to A, apply the function matrix form. So this two double line says apply the function matrix form to the matrix A and see the matrix. Now similarly, you can create B. I think Kai, the submission guideline, I don't think it says which software to use. Whatever that you do, it should be a PDF. Okay, and then for the mathematics derivation, yeah, you can use LaTeX. Yeah, you can take a screenshot and then upload. Okay. And B is equal to 3 by 2. 3 by 2, let's say it's 3, control comma, 2, control enter, 4, 1, control enter, 0, 1. Okay. And this B, and let's create matrix L. L is a 3 by 3 matrix. So, I want to say it's 1 to 5. Control 1 to 5. Control enter. For the next row, 3, 4, 1. And control enter. 6, 0, 2. That's matrix L. Okay. I want to see the output. Let's see. And the next task is, this is easy. I just gave this just to show how to do this in Mathematica. A plus 2A. So if you want to say 2 times A, like this is 2 times 2, 4, 2 times 1, 2, 2 times 3, 6. So that's correct. And the next row is also correct. And then if you want to say A plus 2 times A, that's it. And then show me it in matrix form. Okay. You guys okay up to that? That should be easy. Now, matrix multiplication can be done in two ways in Mathematica, either using the dot function or the dot operator. So let's say A dot B, is that 10, 8, 19, 8. You can check this with the dot function. Dot. How does that work? Let's say product of vectors. Okay, so A, B is the same thing. Now, now you can use a Mathematica for matrix multiplication, but how do you use compute it by hand? Okay, does anyone have any trouble showing this in by hand? Suppose if you want to write down your solution, okay? Do you want me to show it? I'm assuming this is very basic, but if you want, I can show. How do we do the outer product? I'm not really sure what do you mean by outer product. Can you explain more? Or do you mean like element-wise? If you want element-wise, use power. Or this one, the star. That's the dot function. Is that what you're asking? Kai. Cross product. How about, I haven't done, I don't have an example yet, but I think if you go to this website here, it does give you guidance on how to compute various products. Okay, if I am right, it should be star. Okay. Let's do the square and cube of L. L square means L times L, L cube means L times L times L. Okay, you can use matrix power function to do that. Let's say matrix power. How does that work? Okay, it gives you the nth matrix power of the matrix M. So the first argument is your matrix, and n is like which power you want it to be. So let's say I want L squared. And that's in matrix form. Is given by that. Okay. Similarly, to get L cube, you can change the 2 to 3. where did I define L? Oh, at the very beginning. That's where I defined L. It's a 3 by 3 matrix. Okay, the next part is about taking transpose. So in general, to take a matrix, a transpose of a matrix, you change the rows to columns. So let's say we do transpose of A. Okay, if you don't know how to use the function, just have a look at it. Okay, this accepts a list, so A is a list, transpose of A. Let's see if this gives you the correct answer. So it got 3 rows. Is that what we want? And 2 columns. Yeah. So this is a 3 by 2 matrix. So if you transpose A, it should be 2 by 3. Okay. And the first, sorry, 3, it should be 3 by 2. So the first row should be 2, 1. Do we have that? Yes. And the first, second row should be 1, 4. Okay. And the third is 3, 2. Okay. Got it? And if you want to see this in matrix form, you can matrix form. Okay. Okay. The other way that you can use transpose is you can use keyboard shortcuts, which is escape plus tr plus escape. Let's say A, escape, tr, escape. We get the same thing. Okay. So how about you try B transpose? Can we find this record in playlist? This is recorded. Yeah, I haven't stopped. This should be recorded. Yeah. Okay, the next task is okay, B transpose times A transpose. Compute that product and then compare the result with A, B, the whole thing transpose. Okay. This is a known result and you should expect what it should give you. So let's try it. B transpose times A transpose. Escape TR, escape times A, escape TR, escape. Okay. The first row is 10, 19, second row is 8, 8, and compare the result with AB transpose. Okay. Transpose, and I should say A times B. Okay, this you got the same thing. Okay. By the way, you can use matrix form to visualize this. Or just say, okay. Now, does the result hold in general? Okay. Can you prove it? Do you want me to prove it? Should be known result. Okay. Is there any questions so far? Okay. Let's look at the next one. Compute the determinant and inverse of L. Check the computed determinant is the same if you compute it by hand. Okay? Now, determinant of matrix, you can use that function to compute determinant of L. It's -112, but how would you compute that by hand? This is a 3 by 3 matrix. Okay. Does anyone want me to show you how to do that? Okay, you can do it, right? So that is like I have started computing it. Yeah. So it would in general you would get something like this formula if you evaluate it.
Attention, following will be a test of the fire evacuation system. These will be test tones and test tones only. Please disregard. I repeat, the following will be test tones only. Please disregard.
Okay. How? Yeah, that's a fire drill. Okay, there is a question, how do we input a transport? Which key to use it? It's given here. Use escape plus TR and then press escape. Okay, this is something that you need to understand thoroughly if you want to compute it by hand. So the task is create an n by n matrix. Let me show you your question 2. So in the first part, it says create matrices A, B using this formula. Okay, so I'll give you one example where you can create a matrix A using a given formula, both in a Mathematica and by hand. You can assume the dimension, whatever dimension that you want. Okay, if you want to do it using Mathematica, you can use the table function. Let's say matrix A equals, I've used it previously. Let me clear A. A equals table. How does this work? Okay, there are various ways that you can use this. But to create matrices, you can use the last one. Okay, it is your like given expression. That's the I row, j, that is the column, and like the minimum and maximum of the rows and columns. So let me do this. Okay, is your functions I plus j, and I goes from 1 to, I want to create a 2 by 2. And j goes from j, maybe 1 to 2. How does this work? Okay, you got a matrix in this form. Okay. Now, to do this by hand, you can assume I goes from whatever number that you want, 1 to m. Let me show you this. To do that, I will have to stop the laptop screen and go to my notepad. Let me create matrix A here. If n is, let's say 2, so it's 2 by 2 matrix. I want to create it using the formula given. There should be. So in this case, I goes from 1 to 2. I is in, so this is a different question. 1, 2, and j is also 1 to 2. So that's I, j, 1, 2, 1, 2. The expression says Aij equals, Aij is I plus j. So applying this rule, if I is in row 1, this first row, first column, that means I is 1, j is 1, I plus 1 is 1 plus 1, and first row, second column, I is 1, j is 2, so it's 1 plus 2, and second row, first column, I is 2, 2 plus 1, this is 2 plus 2. So you should get the matrix is 2, 3, and 4. Okay? Now, if you have some other rule, let's say it's I plus 2j, okay? Then these will change accordingly as well. So in this case, if I is first row, it's 1 plus, first row is 1 plus 2j, so it's 1 plus 2, 2 times 1 is 2, and 1 plus 2 times 2 is 4, and 2 plus 2 times 1 is 2, and 2 plus 2 times 2 is 4. Okay. So that gives you 3, 4, 6. So that's how you are like, you can create your matrices by hand. Now, there was another part which says, which I have asked you to find another matrix, which is how do you compute in general the entries of matrix C, where matrix C is A times A. So in this case, using this rule here, okay, I plus J, you can generalize, find a formula for this one. That is, so in general, the ith row elements are given by the sum of aik times akj. Okay. Now applying the rule, you get k equals 1 n, and this entry is I plus k here. That is I plus k, and this one is k plus j. Evaluating the two brackets inside the sum, expand the two brackets, you should get I times k plus ij plus k squared plus kj. That will give you, because this is a finite sum, you can evaluate the sum k equals 1 to n. Oh, a lot of chats. Kai has asked, why do we define a matrix this way? Is there any application? One application is like if you do question 2, you will realize that you can generalize matrices like this. I'm sure there will be applications, but on top of my head, I can't think of it at the moment. But we'll let you know later on. Can you please repeat how the formula works? Which formula is it? Which formula is it? This one? Creating the matrix? Sky? Or just to show this, this is a general formula which you should be familiar. If I need to, if I have time, I'll show this, but it needs a little bit of background. Okay, that is like row times column multiplication. Okay, let's say let me demonstrate this by an illustration. So you want A times A. This is equal to, let's say, A11, A12, A1n, A, yeah, is some of the inner products, okay? Is that fine? Or otherwise, A21, A22, A2n, and it goes in one. And you would do the same thing here. A11, A12, A21. And for each row, let's say the ith row and jth column. Okay. Is given by so okay, that would be the outer matrix times the A1j, A2j, ANJ. Okay. And this, if you expand it, it's A1j times. So you got this is A11. Yeah, A1n, AN1. ANN. Okay, this is A11, AN1, okay, plus so that's 1, A2j plus 1, 2, AN2, okay, plus ANJ times A1n up to ANN. Okay. So the ijth row entry in row I of this vector is given by AI1, A1j plus AIN, ANJ, which is the sum of AIQ, AKJ, K goes from 1 to N. Okay. All right, let me continue. Now we are up to here. From here to here, you would evaluate the sum. I hope that answers your question. Um, that is ik plus ij k goes from 1 to 8 plus sum k squared k goes from 1 to n plus sum of kj k goes from 1 to n. Okay, now simplify this again. See that this sum depends on k only, so I is a constant, so you can take it out. K n k equals 1 plus for this sum I and j are constants, so that's n k equals 1 plus sum of k squared and k equals 1 plus in this sum j is constant, so take it out. K and k equals 1 which is equal to I'm gonna collect the sum of k's plus j sum of k and k equals 1 plus here this is like sum of 1 plus 1 plus 1 plus n times, so it's I j n plus sum of k squared and k goes from 1. Okay, now you can use in your assignment you're asked to show this using Mathematica, and you're asked to prove this. So if you use what is given here and sub that expression for these two sums, then you are done. Okay, any questions so far? All right. I'll show you how to do this this sum in math. You can use the sum, find an expression for these two sums in Mathematica. Let me go back to description. Okay, to find the sum of k, you can say it's sum of k. K goes from 1 to n. Okay. That should be the same expression as given in your assignment question. And if you want to find sum of k squared, okay, it's sum k control 6 squared equals from 1 to n. That's the formula for sum of k squared. So in the expansion of the sums that I've shown you previously, you can check these expressions and then simplify. That's it. Okay. Any questions? No questions. Now, question 3 is I'll show how to generate 2 by 2 matrices using random matrices using uniformly from this set. Okay. We can use random integer function. Let's say you want to generate matrix A. Oh, just clear it. A equals okay. How does random integer okay, work? Okay, if you use the first one, we're going to use this one here. Okay, so you give a range, gives an n by n array of pseudo-random integers. So that your range would be the set which you have given here. That's 1 to 3. And then the size of the matrix that you want. Okay, so that could be 1 to 3, 2 by 2. Range is from 1 to 3, and I want to generate 2 by 2 matrix. So let's see if this works. Yep. Okay. So and then try shift enter once again. If it is random, you should see a change of the elements. Okay. All right. And then you can create a function to generate random matrices from this function random integer. And so every time you draw, so question 3 part C, okay, you are asked to find a probability whether A times B commutes. So let's say B is equal to random integer. I'm trying to build that Monte Carlo experiment, so maybe we may not be able to finish. 1 to 3, and another matrix 2 by 2. That's B. And then you can check whether A times B is the same as B times A. Is different this time. So my idea for this part is to use a module function with while. Okay, so I will develop this code and then post it on GitHub. In the meantime, you guys can try it as well. Any questions so far? Okay, we are almost time. Yeah. Zihan.
Hello, Amina. Can you change to the assessment page?
Sorry.
Can you hear me?
Assignment page.
Yes. Yes. Question 6.
Yes, we are out of time, so I'll stop the recording. Let's see.